So we've been doing some average atomic mass problems, and one of the things I didn't really want to put it in your summer assignment until I got to talk to you about it. But it's not enough to know how to do an average atomic mass problem. You also need to know the process that we use to find the data for that problem. And the process is called mass spectrometry, okay? And mass spec for short. And it's a machine. We don't have one at the school. They're incredibly expensive, and when I show you the process, not really something you want hanging around the school because it could be, kind of dangerous. So here are the steps. And so I'll expect you at some point to know the steps for mass spec: vaporization, ionization, acceleration, deflection, and detection. So you take a sample of an element. If it's not a gas, you vaporize it. Okay, so when something's vaporized, that just means you turn it into a gas. And so it's a heating element. I know it's an awesome heating element, and I drew there, and then the sample gets passed on where it's ionized, and so the electrons are knocked off of it, and that gives it a positive charge, and then we accelerate it through these two electric plates, and then it gets bent by a magnetic charge from these two magnets here. And so think about it like this: the bigger the mass, the harder it's going to be to bend. Okay? Think about turning a big 18-wheel tractor trailer and turning a bicycle. It's much easier. The bicycle has a much tighter turning radius. And so the less mass, it's going to turn sharper and come here. More mass, it's going to turn less sharply because it has more mass there, and it is going to hit like right here. This is something that I can explain to you, but it's also one of these things that, who thought this one up the first time? And in truth, it's the result of, countless scientists, people whose names, maybe we do remember, some we don't remember, and it's a process how these things happen, okay? So here, what I'll do is I will draw sort of the path of some ions here. So it comes here, and then here's another one. And so you see the path here of the heavier isotope is going to end here. The lighter isotope is going to make a sharper turn and end there. And then we can use the mass spec to print out this nice little graph that has the abundance and the mass. And so we realize we have more of the heavier isotope.